Good evening. I am Tilak De Silva. Today our topic is telecommunication and IT infrastructure. So there is a presentation, but I am not going to follow the presentation as it is because this series of lectures are not just lessons, because these are some guidelines. So to get ready for the B paper, from these guidelines you have to read and you have to find out the necessary information and get ready for the B paper. So telecommunication and IT. Why we need IT these days and telecommunication these days? Now you have your mobile phone. If you forget your mobile phone, how do you feel? You feel that you are just isolated. So if your email is not working properly, your communication may be stopped. If you cannot go to internet, you may not be search something you want to find out. So therefore, without our knowledge, we always need the connectivity. Connectivity become a part of our life. Second thing is the information. Today we live with information. Without information, it is very difficult to survive nowadays. Now, if you have proper information, you can take the proper decisions. Now, consider if you have a method that if you go by bus, at what time the bus is coming to the bus hold, then you don't want to go there and wait for a long time. If you travel by train, if you know at what time the next train will come to the station, you can save a lot of time. Also, if you want to buy a ticket, say train ticket to Badulla, you may have to go to Fort Station and purchase that ticket. See how much time you have to spend for that. But if you can go online and purchase that ticket, you can save a lot of time. So therefore, nowadays this ICT, information and communication technology, plays a vital role in our society and in our life. Now it is very useful to engineering also. In this B series of lectures, we are expecting to give you something that how it is useful to our engineering field. Now we have some lecture slides. Here the first slide says what is ICT, information and communication technology. This is extracted from Wikipedia. You can just read about this. Then, to whom you need the ICT? We are individuals, we need the ICT, communities we need, enterprises we need, and government institutions we need. Everywhere we need the ICT. So therefore the ICT became a fundamental right of the people. Actually connectivity is a fundamental right of people. If somebody cannot get the connectivity, say remote village, so that means we are depriving their rights. So therefore connectivity and the information became a part of our life, and that is our right also. Now you might heard about the Telecommunication Regulatory Commission of Sri Lanka, TRCSM, or in short we say TRC. What are the functions of the TRC? Now TRC is a regulatory body. We are governing the telecommunication and IT industry. Now you can go to the www.trc.gv.gov.lk website. So I have already opened that one. Here this is Telecommunication Regulatory Commission of Sri Lanka. So please visit this website. There you have the different areas. Now you have icon called industry. On the industry you have the spectrum management, telecommunication network, licensing, economic regulation, internet and broadband. For instance, when you go to the spectrum management, so it gives the what is the spectrum management policy, spectrum management planning, frequency assignments, frequency licensing, spectrum monitoring. So here the spectrum is the frequency spectrum. So frequency is a resource to the country. Therefore we have to properly manage the frequencies. If you do not properly manage the frequencies, it is just like we are not properly manage the height of the airplanes are flying. That means the air traffic controlling. If you do not control air traffic, what will happen? There can be collisions. Similarly, if you do not manage the frequencies properly, there can be interference. And different frequency bands are used for different purposes. For instance, the mobile communication, we have one frequency band. And TV broadcasting, we have another frequency band. And radio broadcasting, we have another frequency band. Now, regulatory body decides how many operators can come to the scene. For instance, the telecommunication operator, mobile operators. So they will decide, okay, this is the maximum number of operators we can allow. So one reason is, when there are more and more operators, there will be more and more competition, but it can be badly affected for that industry, particular industry. But if there are less operators, then the less competition, then the customer will not get the benefit of that one. So therefore the spectrum management is a very important part of the country. So that is looked after by the Telecom Regulatory Commission. Then under that one, actually under the spectrum management, different things are there. When you go to the public, what are the services? Consumer information, downloads. Now, when you get a connectivity from a telecom operator, they might say this package is say 5 megabit per second download speed. If it is not there, who will look after that part on behalf of the customer? Actually, this Telecom Regulatory Commission imposed the compliances to these companies. So always there should be average of this much speed. It can be the minimum speed this much. Those things are given by the Telecom Regulatory Commission. So then the operators should comply to those requirements. So that is one area. Then go to the policies. They have the policies and the legislations. Under the policy, telecommunications, the tower policy, frequency allocation policy, numbering policy, those things are there. Then therefore, for your B paper, please visit the Telecom Regulatory Commission site and study what are the things happening there and what are the things they are doing. Another important agency is the ICT agency. ICTA. So they ensure to create digitally inclusive Sri Lanka in 2018. So this is looking after by the Minister of Telecommunication and Digital Infrastructure. So there are key objectives: smart government service, smart citizen centric government, smart enterprise, those things. So we'll go to this site and see what are the functions of the ICT agency. So Actually, the Telecom Regulatory Commission is a very powerful one. So they are the regulator. So ICT agency will provide the required guidance and the policies for the ICT area. When you take the Telecom Regulatory Commission, they look after the telecommunication part also. So they have different projects. And Digital Sri Lanka, under that one, they mentioned about the digital infrastructure. In view of digital empowering Sri Lankan citizens by way of a knowledge-based society, ICT sees digital infrastructure as its most invested strategy. So, our IT infrastructure or the digital infrastructure is the important part of the ICTA, and their legal framework and development, policy frameworks, then what are the projects they are doing, all these things are in this ICTA website. Now, now consider government agencies where you have to work with them. Now consider any immigration department, issuing of the passports. So these things are very high level of IT actually. They are using IT very well. Now the ICT agency is supporting to them to go to that level. Now actually the good side is most of the government agencies are using the ICT. Now for instance the EPF. Now those days to get the EPF you have to wait for a long time. Now it is very fast. In the pension department, sometimes the people were waiting for pension for more than 2 years. But now it is very fast. So therefore the government agencies or the government institutes are using ICT very well. Maybe after about 5 years, maybe fully digitalized systems will come. So as engineer we should aware what are the things developing in the country in this area. So when I go to the main presentation, now these are some statistics about the Sri Lanka telecommunication. Our population is about 20 million and our mobile penetration is 117%. That means one person may have more than one SIM, not actually mobile phones, SIMs. So and the internet penetration is 19.3%. Now the internet and the education, there is a connectivity. Therefore, if a particular country has the higher internet penetration, the education and the productivity of the country also increases. And voice is the oldest communication or mode of communication, and for the voice delivery we need the copper lines, CDMA, and the mobile networks 2G, 3G, 4G, etc. And for broadband delivery we have different technologies, the LTE and TDD means the time division duplex. That means normally to transmit you need one frequency, receive you need one frequency. So that is frequency wise we are using two, that is frequency division duplex. Time division duplex means this particular time slot you are transmitting, next time slot you are receiving, that is called TDD. And the HSPA, high speed packet access, WiMAX, but WiMAX is not, it was not a popular technology once the LTE came. Then the ADSL is a technology we use for broadband via the copper wires. And FTTH is the superior technology where the fiber is coming to your home. So the bandwidth or the speed of the fiber Normally we have available in Sri Lanka 100 megabit per second. Actually these speeds, we started from the dial-up modems. You may remember the dial-up modems. We connected your dial-up modem to the telephone line, then you went to the internet. There your speed was about 20 kilobit per second. The speeds were 9.6 kilobit per second, 14.4 kilobit per second. So likewise very less speed, those are kilobit per second. Then after that we came to this ADSL technology, where ADSL normally you can get 512 kilobit per second to home, even 2 megabit per second speed to home. So that speed about 1000 times, 100 times speed was increased from the ADSL when you are comparing to the dial-up connection. Nowadays I think nobody use the dial-up, but almost everybody has the ADSL connectivity. But ADSL bandwidth also not sufficient for some of the applications. Now earlier we used the voice line only, the copper line only for voice communication. But now not only the voice communication, to go to the internet also we are using the voice line. So if you want to get the broadband connectivity to the internet, you can use the voice line for, or the copper line for that purpose. Now we are using another application through the copper line, that is the IPTV. Because nowadays the all technology is going to the IP, Internet Protocol. Then through that one, lot of applications you can run through the copper wire. So mainly you have the voice, then you have the internet, and you have the IPTV. Those applications are there. Now you can see very less antennas can be seen for the TV. Most of the people, they get the TV connection via copper wires or from satellite. So copper wire, you can get all these three services. But when you say the TV, you have the standard TV. Now the new ones are high definition TV, HD TV. Their resolution is very high. Then you have the 4K TV. 4K TVs, the resolution is very much higher than the high definition TV. Now it is even the 16K TV is available in the world. From all these things, we can have a very quality pictures. But the problem is when you go to the more and more resolution, you need more and more bandwidth, or you need more and more speed. So when you consider the TV signal, you need several megabit per second, maybe 4 megabit or 5 megabit per second speed to provide that connectivity. So when you consider copper wires, the bandwidth of the copper wire depends on the distance. You know, according to the Shannon's law, the bandwidth is a function of signal to noise ratio. Therefore, when the distance increases, your signal to noise ratio decreases, therefore the available bandwidth of the copper cable will be reduced. That's why you cannot get the IPTV for longer distances. From the exchange up to about 3 kilometers you can get the IPTV. But if it is more than 3 kilometers you cannot get the IPTV from the copper wires. That limitation is there. But if you go to high definition TV, even about 1 kilometer you may not be possible to get the high definition TV. If you go to 4K TV, then maybe only 200 meters. 16K maybe 100 meters distance only. So therefore copper is no longer a good solution for high bandwidth applications. Then what is the media we can use? We can use fiber as the media. The fiber has an enormous bandwidth. So therefore nowadays the telecommunication network changed from copper to fiber. That technology is called the fiber to the home. Fiber to the home is called the FTTH. So that means the fiber is coming up to your core. So then how much bandwidth you have in the fiber? Fiber also depends its distance, but even you can go 20 kilometers from the fiber with a very large bandwidth. Through that fiber you can get even 100 megabit per second speed, whereas normal ADSL you get about 2 megabit per second speed. Then if you want to increase that to say 250 megabit per second, you have to just do the configurations only in the both sides, exchange side and the customer premises side. So you don't have to do any hardware changes there. But even you can go to 1 gigabit per second speed through the fiber. Therefore, once you have the FTTH connection, then you have the advantage of even go to the 1 gigabit per second speed. Now some of the countries already provide the 1 gigabit per second speed. For instance, the Hong Kong, they provide 1 gigabit per second speed. So why we need such a big bandwidth? I mentioned about the TV, but TV is not the only application we have. Now we have many applications through the internet. Now we can listen to songs through the internet. We can watch movies through the internet. There are applications you can watch movies. Now one of the application is the Netflix, Netflix. If you have a Netflix application, so actually you have to subscribe to them about $10 per month, then you can watch any number of movies through the Netflix. So you have the standard TV, you have the high definition TV, even you have the 4K TV. But problem is, for all these things you need bandwidth, high bandwidth you require. So therefore if you have a fiber connection to home, you have a very large bandwidth. So therefore fiber becoming a very essential part of the communication network, that is the customer side communication network, that is called access network. So then many applications we can run through the fiber. Different applications are running through the internet. These are called the over the top OTT applications. The different applications running through the internet is called the OTT. Depending on the application, the required bandwidth is also changed. So now apart from that, we are getting the connectivity through the mobile. You have the second generation 2G, third generation. Now the 2G is the GSM, the global system for mobile communication, GSM, and you have the 3G. Now we are coming to the 4G, that's the LTE or long term evolution. So now it is about to come to 5G also. So these technologies also, when you come to the 4G technologies, LTE, it has a very high bandwidth. Even they can give the peak bandwidth of 40 megabit per second. So by using the different techniques, especially the antenna techniques, you have the smart antennas, the techniques like multi-input, multi-output MIMO antennas. This bandwidth, the effective bandwidth could be increased. So therefore the mobile communication also, it is also the developing very fast. So the mobile applications also increasing. When you get a smartphone, you can see how many applications you are using. Now for instance, if you want to get a call, nowadays the young generation very hardly get the normal voice calls. So they are using the application to get the call. They may use the Viber, they may use the WhatsApp, that kind of application. That is data connectivity. Through the data you are getting this application. These applications are called the OTT or over the top. So through the mobile also we can get many applications. So thing is, the mobile compared to the fixed line connections, mobile cannot give very high bandwidth comparatively. So and the mobile cost is comparatively high. Therefore the technology what we do is in the fixed line communications, when you have the broadband connectivity, from that one you get the wireless connectivity in that area, Wi-Fi connectivity. So normally when you get ADSL connection or FTTH connection to home, you have the Wi-Fi at your home. So then your devices are connected to the Wi-Fi. Now if you are using your mobile phone for a particular application, when you come to home, it is automatically switched to a Wi-Fi. So therefore your downloading is done through the Wi-Fi. It is automatically happening. So by that way you can reduce your cost. So therefore the connectivity is now very advanced, and it's used in an economical way to the people. So these are some statistics about the Sri Lanka's telecom or the IT industry. For instance, the fixed access services, wired telephone line, how many are there in 2015? These are in thousands. This is we have a total of 2,601,000. When you say the fixed line, there are two types. One is the wired fixed lines, other one is the wireless fixed lines. Now when you say the CDMA, it's a wireless fixed lines. Then some other statistics also there. So the telephone penetration, fixed telephones, cellular phones, those things. Now user behavior, that how much data they are using. Now when you see the voice traffic forecast is grow 19% by 2020, but when you say the data traffic, it is going to 340%. The reason is we are using more and more applications through the especially mobile phones. Now if you want to watch the TV, now you can watch the TV through the mobile phone. So therefore you need a lot of bandwidth for the data. Then we have to get, our infrastructure should get ready to provide this amount of data. So because of that, the Telecommunications Regulatory Commission as well as ICT agency, they have to see how much bandwidth is required average per user by 2020. Then how our infrastructure should be get ready for these things, and how our spectrum is managed to provide this bandwidth, and what are the technologies we will use. Sometimes they might say, okay, 2G cannot be used after this date. Some countries doing that, because your spectrum you cannot give to 2G because you need a higher bandwidth, but if you use the 2G you don't have higher bandwidth. Then they say, okay, we scrap the 2G after this date. So these decisions are taken by the Telecom Regulatory Commission. Now they will see how the connectivity can be given to the people, and connectivity can be given for the institutions at affordable prices. Then only people will use the technology. Now is the video traffic from YouTube of OTT, over the top video source, and these are, you can see the different type of technologies we use: LTE, wideband, CDMA, HSPA, GSM, and Edge is the same technology at the higher bandwidth, and CDMA and other technologies. So this is how the broadband subscribers increase, fixed broadband and the mobile broadband, and green line gives the fixed plus mobile. So network performance will be the key motivator for customer to buy a connection. If you get a connectivity, if you don't have the proper required performance there, then you are in trouble. Suppose you get a IPTV connection, if the required bandwidth is not there, then you cannot watch the IPTV. So therefore the performance of the network is a key factor nowadays, because we are depending on these things. Suppose your internet out for several hours, you cannot wait for that one. So therefore these are some key factors: network performance, value for money, ongoing telecommunication tariff plan, So different things are there. So network infrastructure. So here this is the mobile evolution. So 1G is the first generation. So those days we used mainly the analog based mobile communication. Then the second generation 2G, this was designed only for voice, and the technologies for GSM and CDMA. When it is come to the 3G, third generation, so they wanted to have a worldwide standard. When it was the 2G, it was not worldwide standard. When you have mobile phone, when you go to another country, you are not sure whether you can use it there or not. But when it is come to 3G, so it's going to worldwide standard. Now it is the 4G, those technologies are IP based. Now we know most of the applications are now running on IP. One of the applications is the TV, IP TV. Then you have the radios. Through the internet you can listen to the radio. One of the applications is the tune in. From that one you can listen any of the radios, any of the radio channels in the world. So this IP based platform, if you are not doing telecommunication, you don't want to worry very much about these things, modulation scheme, those things. And the higher order MIMO is the multi-input, multi-output antennas, more data density, high speeds for customers. So this is the technology changes. In 1980 1G came, 1991 2G, 1999 2.5G, 2001 3G, 3.5G 2005, and the 4G came in 2010. And these are the different technologies used: GSM, HSPA, HSPA plus, LTE TDD, LTE FDD, LTE advanced. So this is some idea about the GSM technologies. Here the mobile station means the mobile phone. Then the BTS, the base transceiver station, it is connected to the base station controller. BTSs are connected to BTS controller. It is connected to the switch. Through the switch you are connected to the other networks. So this is the technology part of that one. This is the wideband code division multiple access WCDMA. So these are some technical jargons. So you can see the different bands used for the WCDMA. So uplink is this frequency, downlink this is, but these things are not very much useful for your B paper, just for your information. And the LTE stand for long term evolution. It's the 4G technology. That also has the LTE FTD, LTE TDD like that. And when you take dialog has the both, and dialog Mobitel has the FTD, their frequency band is 1800 megahertz, and LTE TDD is there, and we are using this Sri Lanka Telecom 2600 megahertz. So the standards are 3GPP, release 99, release 6, release 8, like that, different standards. Now there are standards bodies to provide these things. The European Telecommunications Standard Institute is one of the bodies, ETSI. Now I have mentioned about the TRC. Similarly, you have the very important bodies, the European Telecommunications Standard Institute, ETSI. They mainly provide the mobile communication standards. Then the IEEE, so they provide the required standard for the computer networking. So when you consider the Wi-Fi, it is IEEE 802.11 standard. Then the ITUT, so they are looking after the whole telecommunication part in the world. So these are the standard bodies giving the standard for the whole world. Now, when you consider the telecommunication infrastructure or IT infrastructure, you have the access network, and you have the transport network or the core network. So it is just like normal road network. The road network, from village to town you have the access roads. Then the town to town you have the highways. In addition to that, we have the expressways also. So the telecommunication network also similar. Here you have the transport network architecture of a typical operator. Now, these things are not very important if you are not doing the telecommunication, but our transport network is a key part of the network, because the access network you can have the copper or radio or fiber, but when you come to the transport network, you need very high bandwidth network there. Now, for instance, in IPTV, if you want to see a previous channel, previous program, then you have to go to all the way to the IPTV headend and get that program to you. Then that is a unicast. That signal is coming to you only. But if it is a live program, it is a broadcast. The same signal is coming to everybody. But when it is a unicast, you need, each person is a separate bandwidth. But if many people watch the IPTV, the previous channels, previous program, then each and every person is a separate bandwidth. Then the large bandwidth is required. So that bandwidth is coming mainly from the transport network. So therefore, designing of transport network is very important. Now, Telecommunication Regulatory Commission considered this as a very important factor, and they have decided to have a national backbone network. This transport network also you can say the backbone network, national backbone network, and they have given they are implementing a national backbone network where all the operators can share that bandwidth. The advantage of that one is there will be no monopoly for that network. Then if there is no monopoly, the cost will come down. When the cost comes down, ultimately that advantage passes to the customers. Therefore, the internet or the bandwidth connectivity, the bandwidth cost will be coming down. So the transport network is an important part of our network. Now you can see you have the access network, then you have the aggregation network, then you have the core network. Three parts are the access, aggregation and core. For you, this access part is the important part because it is coming from your home or from your office. So this aggregation network is just like the outer circular road of the express highways. So they will collect the traffic and put it to the express highway here, core network. So in Sri Lanka now all these networks are expanding and the bandwidth is increasing because of mainly the fiber technology. When you take the fiber technology to point connectivity, you can have one fiber. So you may send even 100 gigabit per second speed through this fiber. But the same fiber can be used as a virtually many fibers, because within the fiber you can use different lambdas, with different wavelength. So you can do the wavelength division multiplexing and send large amount of data through the fiber. So therefore one fiber will act as a virtually many fibers, even maybe 100 fibers. So therefore in this fiber network we have a very large bandwidth. Now our connectivity, it can be national level, local level and international also. How we will get the international connectivity? Now about 25 to 30 years back we got the connectivity through the satellite. Now the international connectivity we are mainly getting from the fiber. We have the fiber submarine cables. So there is one slide here, it says how many submarine cables are landing in Sri Lanka. We have the CMEV 3, CMEV 4, CMEV 5, like that, different names are there. CMEV in the Southeast Asia, Middle East, Western Europe. So it will cover all these areas. Now since our aggregation network, core network and the international network all are fiber, so we have enormous bandwidth in the network. So it also cost effective and our cost per bandwidth also going down. So you can see the transport network technologies. I told about the optical fiber. In addition to that, the microwaves and the different technologies are there. Now when you take a fiber, there can be 16 core, you can have the 32 core, 128, 256, even 1024 core fibers available nowadays. So therefore once you lay the fiber, then you have a enormous amount of bandwidth even for future. So that is the beauty of the fiber technology. So microwave we are using for the terrains where the fiber cannot be laid. So hilly area like that, so we can use the microwaves. So some theories are there, but these theory parts are not very useful for your fiber, but for your B paper, but you can get some idea about how the fibers are laid. For these infrastructure developments are happening in the country. The reason is the government is forecasting, especially the Telecom Regulatory Commission, how much bandwidth is required by end of 2017 per person and for government institutions. By 2020, how much bandwidth is required. Now, government is planning to digitize almost all government institutions within about 5 years. Then most of the things are doing by online. Now to do online, you need large bandwidth there. For instance, consider the hospital. Hospital, they can send the X-rays and those things. They are coming to digitize. So the consultant may be in a very far away. So you can get the reports from here, and through the network we can send to him. He can see it from there. Then he can give the medicines to while looking these reports. So that is in the hospital area, health sector. So health sector, these things are developing. Then only thing is that you need a large bandwidth. Then the hospitals are required large bandwidth. Then the government should plan to give the required infrastructure, IT infrastructure or the communication infrastructure to hospitals. Similarly, the divisional secretariats, now most of these things they are doing digitally. So they need a large bandwidth. So they need about 100 megabit per second speed bandwidth for each and every divisional secretariat. So likewise, almost all government institutions you need a large bandwidth. So these are some slides, the optical fiber constructions. You can just see this submarine cable, those are also optical fibers. So this is a little bit technical. So I told you the modes of connected to international networks. One is the satellite links, it's a low speed. Other one is the submarine cables like this. So these are the submarine cables available in Sri Lanka. CMEV3, CMEV in the Southeast Asia, Middle East, Western Europe. All these areas is covered from this cable. CMEV4 and CMEV5 will be commissioned in this year. And this another one, BBG, then the Bharat Lanka cable. Diragu cable is with the Maldives, and the flag. Flag is a fiber loop around the globe. So that will go many of the countries. So these are the submarine cables coming to Sri Lanka. So this is about the international voice networks. Then the international data connectivity. Now, in your organizations, suppose you are not telecommunication, say civil engineering. So to work in the civil engineering, you need lot of IT. So to work with IT, you need the connectivity. So then your branches, your branch officers should be connected to you. If it is connected, then we can make easy many things. Now, Those days if you have a circular, you send the printed copies, hard copies to everywhere. But if you have an intranet, means your private network, your company, you can send that one through email to everybody. Now in Sri Lanka Telecom, we have intranet. So if you want to send a circular to the whole country, within few minutes we can send it to there. So what is the requirement? We have to have connectivity with all the branches. Now how we can economically connect these things? So you can have through the ADSL, fiber, whatever the things you can connect. But when you are connecting, you can have the virtual private network, VPN. You can tell the service operator, okay, I need a VPN connectivity to my branches. So once you have the VPN connectivity, virtual private network, then you can economically transport your data through your network. So if the company's branches are still not networked, so if you do the networking, then your productivity can be increased. So even your international branches can be connected to the VPNs, virtual private networks. So next I mentioned about the spectrum. I told you about the spectrum. Different frequency bands are used for different applications. So these are international frequency allocations, and for all if you use a frequency for your connectivity, you have to get the license from the TRC. But there are some unlicensed band. For instance, the Wi-Fi is working in the unlicensed band. That is 2.4 gigahertz and the 5 gigahertz. Can somebody open this up? Right. So 2.4 gigahertz is the unlicensed band. If you want to get the Wi-Fi connectivity, you don't want to get the license. But if you go to some other frequencies, you have to get the license from the TRC. The quality of service, QoS. So in the telecom sector, the quality of service should be maintained. That is monitored by the Telecom Regulatory Commission. For instance, if you take the mobile call can be dropped. How much rate it is dropping? So the average user throughput, all these things, the performance indicators. Then now the new trends are, one is the Internet of Things. Now I think you heard about the Internet of Things, because we are now connecting everything to the Internet. So that is Internet of Things. Now normally we connect our mobile phone, then the other TV, smart TVs, like those things only. But through the Internet of Things, many things are connected. So consider vehicle. So in the vehicle, each and every part you can have the IoT devices. So if any problem is there, it will inform to you. Even when you want to service your vehicle, if it is about to exceed, that SMS can be sent to your service station also, this vehicle to be serviced, and you also can get SMS. So likewise, through the Internet of Things, you can connect billions of devices. From that one you can get lot of information. So therefore in the B paper we studied about the Internet of Things. So where almost whole world is connected. Along with this one, the smart concept is coming. Smart home, smart education, smart health, All these things also come in along with the Internet of Things. So Internet of Things is enabling connectivity between different devices, and therefore IoT can be called as social media for machines and devices. So normally social media is there for the people, but IoT is a social media for machines and devices. So IoT impact. IoT provide networking to connect people, things, applications and data through the internet to enable remote control, management and interactive integrated services. So number of mobile devices exceeds the number of people on earth. Predictions are made that there will be 30 billion things connected to the internet by 2020. 30 billion of things. Even your home, your key, the lock is connected to the internet. Your fridge inside, so different things inside, they are also connected to the internet. So therefore you can say the 30 billion things are connected to everything. That means almost everything is connected to there. This will come into all the fields, even the agriculture field. So to get the information about the plants and the animals, so we can get these things. From that one we can see their behaviors. Then we can optimize the resources through this one. So, so there's a YouTube channel to go and see what are the IoT applications. Now IoT architecture. Here are the devices, transport, common application, then the applications. So these are the devices, they are the sensors and actuators. So and network infrastructure, Bluetooth, Zigbee, Wi-Fi. So devices are the sensors and the connectivity. So that is this layer. And the transport layer, after that long distance, how do you connect? It can be 2G, 3G, LTE, Wi-Fi networks, etc. Then you have the gateway there, common application, infrastructure, where the security and those things are there. Then you have different applications. Then you can see the smart metering or the smart grid in the electricity, the supply chain, transportation, healthcare, retail, agriculture, smart city. All these things are connected to here. For instance, if you want to get a parking slot, before you reserve a parking slot in Colombo, before you go there, then if it is smart city, you can create from an application, say the parking application, say this particular location, if whether there is a parking slot. From that time you can reserve that parking slot and go. So you don't want to go there and search for parking slot. So that kind of things can be done. This is about the sensors and actuators. This IoT network. Then software defined networks and the network function virtualization. Now we are the change in the technology. Now instead of one computer we are using or the one server, we can have a pool of servers we are using, and everybody can share that one. So that is called cloud computing. So why we call cloud is we cannot see physically this is the server. So maybe one set of servers in Sri Lanka, another set in UK, like that you can virtually connect them and make a cloud. Then advantage of cloud is we can utilize the resources effectively. Now consider you have a PC. Some people are using the PC only for word processing. Then the usage of the processing power may be only 5%. What about the remaining 95%? We are not using that one, that is a loss. But if you can connect all the PCs and share that processor, then suppose there are 10 PCs, only 5% is used in each. Then one PC can be used by 20 people. If there are 10 PCs, 200 people can be used if it is pooled. So that means if you make a cloud there. Then in the cloud computing, we don't want to buy computers. You can go to the cloud, you can have a low cost terminal with you, go to the cloud, then you can rent out your processing power, your RAM, your storage, all these things you can rent it out. So suppose tomorrow you need a very high processing power, you don't want to go to high-end computer, you can get the high processing power from the operator. So that is cloud computing. So therefore even the organizations, rather than having your own servers, you can think about how economically use these things. Now one method is to go to a data center and hire a computer from there. Then advantage of that one is you don't want the IT savvy people to look out for your system. You can reduce the cost by getting the services from the data centers. The next step is not the physical service, we are getting the computer services from the cloud. Then the next one is in the cloud also, you can, in computer you are running different applications. So this application also nowadays running in the cloud. If it is in the cloud, the cost is very low. So you have to pay only monthly rental for that. You can reduce your capex. You need only the opex. So they have to think about your organizations, how you can reduce your capex. So one thing is, rather than you are maintaining the servers, go to a data center and get the servers and rent out that. The next step is you can get the computer power from the cloud, and the next one is even the applications you can run through the cloud. Then the cost is very, very low. Now for instance, our ISL membership management system, it's a cloud based one, so it's very low cost. But next year if you want to go to another system, still we have the flexibility to go to there also. So we don't want to change the hardware, software, these things. Similarly, when you come to the networking, when you take the network, there are network devices. You have the switches, routers, firewalls, like that. Many devices are there. Now these devices we have to change from time to time. So now the cloud computing used for the networks also. Now you have the network device. Any network device is a computer actually. It has operating system, you have the RAM, ROM, these things, and you have the application. Now consider router. You have the router, say particular version. So the next year they will upgrade the version. But the following years they say you have to change the whole box, whole hardware. But if you go to the network function virtualization, these network functions are in the cloud. The basic hardware is with you. So therefore when they are going to the newer version, we don't want to change that. Similar to the applications. Now even the application, say the Word application. So if you want to change go to the latest version, you may have to load that software to there. But if you go to the cloud services, they will automatically update their new releases. So similarly now the network devices also available in the cloud. That is called the network function virtualization, and along with this software defined networks are coming. But these things are not very much useful to the people in the non telecommunication field. But just for your information, this may be useful. So this is the network function virtualization. I mentioned about the ETSI, European Telecommunications Standard Institute. So their NFE reference architecture is given. So they are the people giving the standard for these things. In the IT cloud and NFE, so these are areas the ICT is going: health and safety, green technology, Yeah, now I have another small presentation. Most of the things I discuss is here. So this is the evolution of ICT. So why we need ICT? ICT means for information and communication technology. We need the informations to take decisions, communications for connectivity. Now, all the engineering fields, we have different applications now. Now, from these things, from these applications, we can take very, very accurate and very, very economical decisions. So, when you have the information, we have to store and process them. So, information is collecting your data. So, when you are processing, we need the hardware, we need the database, we have the application software. All these need licenses, and you need the high capex to maintain these things. And communication, you have the local area network, wired, wireless, then the wide area networks. This network, you have the access network and the core network, or the transport network mainly. The access network, you can have the ADSL, FTTH, the mobile, you can LTE. These speeds can be 10 megabit per second, 20, 40, 100, etc. So this is about the cloud computing. So to reduce the IT cost, we can use the cloud. So these are the traditional services. You have the separate infrastructure. Here you have the cloud here. Through that one you are getting from the cloud you are getting the services. That is the shared resources. Different cloud services are there: infrastructure as a service, the platform as a service, and software as a service. Now, when you are working with the cloud, so you can have one smart device with you. Maybe you have a tab or you have a smartphone. From that you can work. But there is a security problem. So when you are working in your office, your information can be leaked. But if you are working in the cloud, so from this concept, bring your own device concept, the security can also imposed. So when you access to the company information, you are working in one mode. So you can get out from that one and you can go to your personal information somewhere, Google Drive or somewhere, you can work from there. So the BYOD is a concept nowadays we have, that is policy of permitting employees to bring personally owned mobile devices, laptop, tablet, smartphones to their workplace and to use those devices to access privileged company information and applications. So we don't want to give separate computers to their employees. We can ask them to give their own device and through that device they can work. So I mentioned about the Internet of Things. So devices as sensors, they are connected to internet, information flow through the internet, and along with this one, the smart concept comes: smart home, smart education, smart health, smart city. Now you can go to the YouTube and get many things about these things. You can say the smart home, what are the features in the smart home, and education, health, even the transport. Now in the transport, recently some Singapore company came and did a demonstration, did a presentation to Morato University, one of the forum in Singapore. Their transport services, they can see how the buses are moving and whether the buses are stopped for a long time in the bus stops or whether they are going fast. All these things can be monitored and they can take the actions against these people, these drivers also. So in that way we can have some kind of control also, some kind of discipline also from these smart concepts. It's a smart cities concept. So you have the infrastructure, then you have the smart buildings, smart energy, smart water, smart transport, and like that. Many things are there. So this is the source. So Another important thing is the analysis of information. Normally we analyze our information based on the past data, but through the big data analytics you can predict, you can predict for future also. So suppose you want to analyze about your customers customer behavior, say the telecommunication operator, this particular customer may be churned very soon. That can be predicted from this big data analytics, the methods. So even your field, you can use the big data analytics and do many things. So these are some deliverables of the big data analytics: customer experience analytics, increase contact center productivity, enhance customer satisfaction. For sales and marketing, you can use for effectiveness of marketing. Once you do the marketing, how much it is effective. Credit risk analytics, market risk analytics, the calculating risk in marketing, effective advertisements. So network in the HR. In the HR, you can use the big data analytics for utilization employees in business critical areas, enhance employee satisfaction. So we can use the application, different applications as tools. So application related to engineering field. Maybe a small application make your office work very useful. But today we have the PR interview, and one of the candidates told in his child school they have a Viber group, and all the information of the class they will get immediately about his child, the homework, all these things. This is a very simple application. Similarly, having sometimes very small simple application make our work very easy. So therefore use the applications as much as possible, then we can make it very easy, make our work very easy. So for this under this guidance lecture, IT and telecommunication infrastructure. So what we wanted to tell you is what are the trends of telecommunication, what are the trends of connectivities, and how the information, how you can economically use the IT infrastructure, how you can economically have your own network, and how the IT can be used as a tool to you for your analysis of the different analytics, and how you can use the different applications for your job. So still if you are not using the appropriate applications, then your work still may be very robust and it is time consuming. So by using this technology, you can make your life easy, you can make your job easy. Now when you get the civil engineering, so now the design is mainly depend on the IT, and sometimes you are doing the designing not only one country, several countries together, where you have the connectivity and the IT is required. So this is some guidance, and this is not the lecture, you are getting the question from this one. So this will give some insight to you, what are the development in the world, what are the things you should know, what are the regulator is doing, and what are the policy making bodies are doing, and what are the trends in what is the trend in our country, and the internet penetration, the broadband penetration, all these things. So you should have some idea. As engineers, you have to use these things as much as possible to make your things easy. So even the working collaboratively, share your knowledge, you can use this IT infrastructure. So if you have any question, I can answer. Any question? So all these guidance lectures are to give you some guidance only. These are not just lectures. So the B paper is there to see your managerial capabilities, and the manager means not only doing your job. You should know what are the other things also, the economical part, the other developments in the country, all these things, because these things are useful to your business also. As engineers, we should not do only the technical part. So we are doing a business. So our company needs profit from our business. So when you are doing business, you should know how to reduce the cost and how to increase the revenue. So that is the thing. Finally, you need to do these things. You can use this technology. Okay.
When we go for more connectivity, the threat is also going higher. Data hacking and the security problems also increasing.
Yeah. So when you share in the network, when you share in the computers, cloud computing, when you share in the network devices, that threat is there. So along with this one, information security is coming. So when you consider the information security, it's a very big part of any company now. So ISO 27001 standard is the information security standard. So you have to have information security policy in the company, and the standards in the company, guidelines. So according to that one, you have to do different testings. You have to do if you get the ISO 27000 certification, then you have to frequently audit your systems. From that one, it will make sure that you have the required security. But still, when the more and more applications are coming, security threat is there. For these things, our solutions also come. So you are correct. Security is a big threat. Yes. Yeah.
When we provide a complete Wi-Fi solutions, what are the equipment that they are using? How we looking at TRC as well for the
What are public Wi-Fi solutions?
Yes.
What?
As you said, for the Wi-Fi frequency, we are getting TRC as well.
I can't follow.
The frequencies we are using for the Wi-Fi.
Where is this mic? Yeah, frequency I get on Wi-Fi. Yeah.
We are not getting TRC approval.
Yes. Yes.
So when we provide a solution public,
Yeah.
we are getting approval.
Public. Yes. Because from all these things, what you do is you have to control the transmit power and some of the parameters, otherwise it can be interfered with the others. But when you get the device, normal device, say the mobile phone, they design this according to those standards, international standards. Therefore, there will be no interferences. That's why in the public places, when you are putting, you have to get the approval from them.
What are the regulations for electric towers?
You can go to TRC.
Yeah, towers and the radiation levels and all.
Yeah, all these things are there. That's what you want to learn actually. You don't want to remember these things. You have to go to the TRC website and see all these things are there. Sharing the towers. Earlier, each and every operator erected the tower. Now, they are sharing the tower. Actually, these directions are given from the TRC. All these things are resources. Any other question? So within next 5 years, there will be big change in the world because of the communication and the IT. So everything will be changed, and the life will be very easy if you properly use that technology. So if you don't use properly, it will be a big threat to your life also. Whether you are just wasting your time like that, but the many applications now also available, we can use effectively those things. For instance, your health. So if you have application, if you can measure the blood pressure, if there is something wrong with your blood pressure, then they can give indication to you. Even that can be informed to the family doctor also. Then they will take the action for that. Similarly, the cholesterol, sugar, like that. And their application, you can see how many steps the you have put how many steps today, how many distance you walked, and how many energy burn, calorie burn. So those things are very useful to us. So if you properly use these things, it will be make our life very easy. So you can save a lot of time also now. A simple application is the channeling a doctor. Those days you have to go early in the morning and get the appointment. Now online you can do. Purchasing a airline ticket, online you can do. So many things you can do online. If you want to travel another country, before you go there you can plan everything. So check the hotels, whether this hotel is good or bad, all these things you can check. Then the online booking, then the competitive prices you can get. So because of technology these things have changed. So even somebody want to get a visa to another country, I think in few years time it is very easy to get the genuine people to get visa, because their whole information is there. Then through the big data analytics or whatever the way, they can check and see whether this person is genuine person. Then they may issue the visa immediately. So these things are happening, and the good people can live happily in the world. Okay. Right. Okay. Thank you very much, and wish you all the best for your BP.